We are going live.
Welcome to the School of Engineering at Dayanand Sagar University, main campus, Harohaldi, Kanakpura Road, Bangalore. A place that values research, innovation, and creativity. Our industry-aligned curriculum offers a blend of theoretical knowledge, practical experience, academic projects, and internships for a rewarding career in engineering. With an interdisciplinary approach, you can explore your interests by selecting open electives. The on-campus innovation labs, led by professors of practice, provide immersive learning and expertise to find the best solutions to real industry problems and give a different dimension to the students' mini and major academic projects. Our Center for Entrepreneurship supports startup opportunities and provides a perfect platform to launch your next big idea into successful ventures. We also prepare you for advanced studies in the latest futuristic technologies. Our B.Tech programs offer the perfect combination of academic rigor and functional experience in this ever-evolving technological landscape of the future. Experience a whole new world of academic excellence in a global environment. Dayanand Sagar University. Live the dream.
Ravi Shankar sir, so over to you. We'll start the class. Ravi sir? Ravi Shankar sir?
Is it audible?
Yeah, now it's audible, sir.
Okay, right.
Okay, over to you, sir.
Good evening, students. Welcome to the session, and today will be the chemistry class taken by the Dr. Ravi Shankar sir, who is having the 25 plus years experience in the CET, JEE and NEET coaching various institutions in Karnataka. And he already taken the session earlier also. Today is the I think second session for him, and today he is going to cover the topic organic compound containing oxygen 2 and surface chemistry. These are the things he is going to cover today, and I think all of you get the good input from, because he is an experienced professor, and he is going to give the very good input for your CET classes. And today, all the students who are qualified in the PUC examination, we are congratulate them on behalf of Dayanand Sagar University. All the students, we are giving the best wishes and congratulate them to for the future entrance exam. Let them do well. And Mr. Dr. Ravi Shankar sir, you can take over, sir.
Okay, no. Dear students, welcome back to our discussions. Last class, we have discussed about organic compound containing nitrogen. We have discussed about isolation of elements. Okay, and today we'll be discussing about very important topic. There are many questions appear in this topic: organic compound containing oxygen. In fact, this has two parts: part 1 and part 2. In a part 1, we are supposed to discuss about alcohol, phenol, and ethers. Whereas in part 2, we are supposed to discuss about aldehyde ketones and carboxylic acids. So let me just take a pen first. Okay, where it is, annotate. Okay, so this chapter we can divide it into part 1 and part 2. And usually around 5 to 6 questions will come here just from this particular topic. And sometimes if you take a related thing, it may be more questions also. So this is a very important chapter, and advantage is that if you study one, you can say that you know part two also. Many questions in part 1 and 2 is repetition. Many topics in part 1 2 is repetition. So if you study second, you can say you know the one. If you study one, you can say you know the second. And most of the topic are interrelated also. So this makes it very interesting and easy also. So let us first start with alcohols. What is alcohol? Any compound having a general formula. ROH, we call it as what? Alcohols. So these are the hydroxy compounds. Okay. And if you take a general formula of alcohol, CnH2n plus 1 OH it is. And in alcohol, oxygen atom undergoes sp3 hybridization. So due to repulsion, the bond angle slightly decreases, 108 it becomes. And CO bond length is 142 picometer and OH bond length is 96 picometer. And if you come to preparation, okay, if you come to preparations, so how many types of preparations are there? One preparation is mainly from what? Alkynes, already we have studied. When alkyne reacts with KOH, remember, not alcoholic, aqueous KOH, not alcoholic. Alcoholic, if you take, elimination reaction take place. Aqueous KOH, what will happen here? Nucleophilic substitution reaction take place, sir, to give alcohol. This is one method. Second method is from alkenes. When you add HX to alkene, you have already studied. When you add HX to alkene, where you have studied? In alkene. We know about Marconi-Kafla and active Marconi-Kafla. Same thing we have to discuss, but not with HX. Here we add water. When we add water in terms of sulfuric acid, it follows Marconi-Kafla. In the same way, if you do hydroboration and oxidation, we call it as. Hydroboration means addition of B2H6. Oxidation means H2O2. By using H2O2, we oxidize it. It follows anti-Marconi-Kafla. Remember this one. So when you add OH group to alkene, when you do hydration to alkene, it may follow Marconi-Kafla also, anti-Marconi-Kafla also. If it is a acid hydration, so it is a Marconi-Kafla. If it is a hydroboration, we call it as. If it is a hydroboration oxidation, sir, what is hydroboration? Addition of a borane. It is an anti-Marconi-Kafla. Then, by using formaldehyde and aldehyde also we can get it. How to get it, sir? By reduction. When aldehyde is reduced, okay, either by using platinum, palladium, or nickel, we get primary alcohol. When ketones are reduced, we get secondary alcohol. And we can use reducing agent like sodium borohydride also, lithium, aluminum hydride also, you can use it. Or sodium and ethanol also, we can use it. There's one more way. By treating with Grignard reagent also, we can get alcohols. By using Grignard reagent also, we can get it alcohol. How it is? So when we take formaldehyde and Grignard reagent, RMGX, we get primary alcohol. Sir, any other aldehyde, if you take, you get secondary alcohol. So if I treat ketone with RMGX, I get tertiary alcohol. Most of the time, this is a very favorite question for any examiner. Okay. Sometimes in a multiple concept question, you will put these things in between somewhere. In first step, in second step, third step, you will just immerse it. Very easy to tell. If formaldehyde is there and Grignard reagent is there, you're going to get primary alcohol. If any other aldehyde and second and RMGX is there, we get secondary alcohol. Any ketone is there and RMGX, we get tertiary alcohol. And from carboxylic acid also we can get it, but we need a strong reducing agent like lithium aluminum hydride or borane. That is again a reduction. So we can get alcohol. So this is all about preparation of alcohol. Sir, what is the physical property? Mainly boiling point. Boiling point is proportional to what? Sorry, boiling point is proportional to size. So it is proportional to number of carbon atom. So it is proportional to number of bonds also. More the bonds, more the boiling point. That's why when you take alcohol and ether, alcohols have a higher boiling point than ether. Why, sir? If you look at the things, both are having van der Waals force. Sir, both are having van der Waals force. Then what is the difference? Difference is that alcohol do have hydrogen bonds, sir, but ether don't have hydrogen. So boiling point depends on what? Force of attraction. More the force of attraction, more the boiling point. So alcohols are having a boiling point more than ethers. Then, just let me clear it. Clear all drawings. Okay, next one. So solubility. Solubility depends on what? There are two things. Is it soluble in water? Yes. Soluble. Why it's soluble? Because it forms hydrogen bond. Anybody who forms hydrogen bond with water is soluble. And definitely soluble in organic solvent also, because it's an organic compound. But solubility is inversely proportional to size. That means number of carbon atoms. More the carbon atom, lesser the solubility. Remember this one. And it is proportional to branching also. So coming to chemical property. So what are the chemical property we are supposed to discuss here? What are the chemical properties? Mainly three kinds of reactions are there. Which are the three kinds of reactions? The one is cleavage of OH bond, one reaction. Another is cleavage of CO bond. Then reaction due to whole alcohol molecule. So these are the three kinds of reaction what we are having in alcohols. When there is a cleavage of OH bond, what kind of reactions are there, sir, here? Here you come across reaction with sodium. This shows that alcohol is acidic. Then reaction with NaOH. It will not react with NaOH. That means it is not a strong acid. It's not an acid, but it is acidic in nature. Then what else? What are the reactions we can discuss here? Sir, we can discuss here esterification. Then we can discuss here acylation. All these reaction takes place here. And acidic nature also. Acidic nature also. I already told you, since it reacts with sodium, it is acidic in nature. But its acidity is lesser than water. And among alcohol, primary alcohol is more acidic. Remember this one. Primary alcohol is more acidic. Then coming to cleavage of OH bond, CO bond. What are the reaction here? Say reaction with PCl3, reaction with PCl5. All these reactions, a reaction with HCl, reaction with SOCl2. So in all this reaction, which alcohol is more reactive? Tertiary alcohol is more reactive. So, and we study Lucas test here only. What is the Lucas reagent? Sir, HCl and anhydrous zinc chloride. We say tertiary alcohol gives you turbidity immediately. Why it gives turbidity immediately? Because that is more reactive when there is a cleavage of OH bond, CO bond. When there is a cleavage of CO bond, which alcohol is more reactive? Sir, tertiary alcohol is more reactive. So in a Lucas test, which alcohol is more reactive? Tertiary alcohol is more reactive. Reactions involving whole alcohol molecule, let us take. Reactions involving whole alcohol molecule. That means due to entire group, ROH group. Due to entire ROH group. Dehydration. What is dehydration, sir? Removal of water. And which is the dehydrating agent? Sir, sulfuric acid is the dehydrating agent. If this reaction takes place at room temperature, we end up getting alkyl hydrogen sulfate. If it is at 443, we end up getting alkene. If it is at 413, we end up getting ether. Remember this part. When it is when alcohol reacts with sulfuric acid. And which alcohol is more reactive? Again, here, tertiary is more reactive than secondary, sir. Secondary is more reactive than primary. What is tertiary alcohol? OH attached to tertiary carbon atom. Then coming to one more reaction, oxidation. When alcohol is oxidized, we end up getting aldehydes or ketones. When that is oxidized, we get carboxylic acids. That depends on the what kind of reagent we are having. So dehydrogenation. What is dehydrogenation? So removal of hydrogen by using copper at not 273, that is 573 Kelvin at high temperature. At 573 Kelvin, at 573 Kelvin, primary alcohol undergoes dehydrogenation to form aldehyde. Second alcohol forms ketone, whereas in case of tertiary, it is given. In tertiary, it will not undergo dehydrogenation, but again it undergoes dehydration. What is dehydration? Loss of water to form alkene. Let me just clear this. Okay. So we can also have some confirmation test for this particular distinction test for this alcohol. The most very easy one is dichromate test. So what is a potassium dichromate test? When primary alcohol undergoes oxidation, they form a acid with same number of carbon atoms. Because primary alcohol gives you aldehyde. Whereas secondary alcohol gives you ketone, which undergoes oxidation to form a less number of ketone, less number of carboxylic acid. Tertiary alcohol, no reactions. Victor-Meyer test. What will happen? Primary alcohol gives you blood red color, secondary alcohol gives you blue color, and tertiary alcohol is a colorless. Lucas test. What is Lucas test? Sir, we are adding HCl and anhydrous zinc chloride. Tertiary alcohol gives you turbidity immediately. What is turbidity? Due to formation of RX, we call it. And in secondary alcohol, turbidity appears after 5 minutes. Primary alcohol, no turbidity, or turbidity comes after eating. So we can distinguish alcohols by using Lucas reagent. And we should know a little bit about methanol and ethanol also. What is methanol? So it's highly poisonous. Wood kettle, we call it a wood spirit. It is widely used in industry as a solvent, preservative, as substitute for petrol. There's a lot of application in a industry. It is called as wood spirit. But nowadays, we can prepare it easily by using what? Sir, water gas. What is that water gas? CO plus H2 by using what? Zinc oxide and chromium oxide to form a methanol directly. It is highly poisonous. Remember, ethanol. What is ethanol? It's prepared by fermentation of molasses. What is molasses? The waste product of a sugarcane industry. That means nothing but sucrose. This is acted upon by the enzyme called as what? Invertase, which converts it into glucose and fructose. And this is acted upon by enzyme called as zymase. And that forms alcohol. Alcohol. And this, what is meant by denatured alcohol? They will ask you. What is a denatured alcohol? Most of these alcoholic beverages are made up of what? Ethanol. And we get ethanol in the industry also. So people may misuse it. So what they do? Commercial alcohol made unfit. Commercial alcohol, which is not available in restaurant, is available in industries. Made unfit for drinking. Unfit for drinking by adding chemicals. Like what? By methanol, by adding chemicals. By adding chemicals. It's called as denaturation. We make it unfit for drinking purpose. Let us go to phenols. So what are the things we have to discuss in phenols? What is a phenol? Phenol is a hydroxy compound again. But here, OH is directly attached to benzene. So OH is directly attached to benzene. That we call it as a phenol. Again, here oxygen undergoes sp3 hybridization. But here, since there is a delocalization of benzene ring, the bond angle remains same 109. Only the CO bond length decreases due to partial double bond character. So what are the methods of preparing this particular phenol? The very common method is cumin. Very, very common method is cumin. Cumin is also called as isopropyl benzene. Is also called as isopropyl benzene. There's a lot of question on this molecule. You can prepare isopropyl benzene by oxidation. You get cumin hydroperoxide or cumin peroxide, which upon oxidation, in next step gives you phenol plus acetone, we call it as. Or we can take chlorobenzene and we can convert it into phenol. What temperature? At high temperature and high pressure. We can convert phenol, benzene diacetyl chloride into phenol. We have studied in our minds by heating with water. Next one. So we can convert benzene sulfonic acid into phenol by treating with what? By treating with NaOH and HCl. So this is the method of preparation of phenols. And coming to physical property, phenol is a colorless liquid, or it may be solid also. And it forms a bonding with water, hence it's soluble in water. Coming to chemical property. So what are the important chemical property? That is, main property is acidic nature. Phenol is acidic. Remember this one. Like alcohol, phenol is also acidic. But phenol is a weak acid. But even though it is a weak acid, it is stronger than acid. So phenol is stronger than alcohol. So phenol is stronger than alcohol. Both are acidic, but phenol is stronger than alcohol. Remember this one. And acidic character is measured by K. More the K value, we can say more acidic. But don't remember this one. K, sometimes you will give it as pK. Both are same. Only the value differs. If pK is less and K is more, that means the molecule is more acidic. And which group will increase the acidic nature? Say electron withdrawing group like NO2, X, cyanide, they will increase acidic nature. Whereas electron donating groups, so they decrease acidic nature. Decrease acidic nature. Please remember, this is all about acidic property of phenol. Then what is the other property? ESR reaction. What is ESR? A electrophile will attack the phenol molecule. Which are the ESR? So chlorination, like chlorination means Cl plus we are adding. Sulfonation means you are adding SO3. Nitration means you are adding NO2 plus. Product of alkylation, here electrophile is CH3 plus. So in all this reaction, what we get? Sir, ortho and para product we get. Why? It is due to activity effect of OH group. So in all ESR reaction, we are going to get ortho and para product. Coming to ethers. What is ether? Any compound having a general formula ROR, we call it as ether. ROR is called as ether, sir. And very common method of preparation of ether is, so mainly two things. One is from what? By using alcohol, sir. Already we have studied by heating it at 413 Kelvin, we can get ether. Or by heating with aluminum oxide at 523 Kelvin also we can get ether. Or by Williamson's ether in the ether synthesis, where alkali reacts with alkoxide to form ether. But here the condition is that Rx should always be primary. Otherwise, if it is tertiary, elimination reaction take place. And this Williamson synthesis involves SN2 mechanism. SN2 means, I told you, no, primary should be there. If you take secondary and tertiary, elimination take place. Next one. So physical property. What are the physical property? These ethers are having slightly dipole attraction. Boiling point is lesser than alcohols because they don't have hydrogen bond, but definitely more than hydrocarbons. Solubility, as I told you before, is due to because it forms hydrogen bond with water. And fairly soluble in organic solvent and lighter than water. So what are the chemical properties in ethers? Mainly, remember this one. When ether reacts with acid, ether is a Lewis base we call it because it has a lone pair of electrons. So base reacts with acid to form what? Salt. Base reacts with acid to form a salt. And the other reaction is cleavage of a CO bond. Very, very important. What is the reaction? Reaction with HX. HX means mainly it is HI. HI. Especially a reaction of what you can call it as aromatic ether. Ether with HI is very important. Or ether having tertiary carbonate with HI, that is also very, very important. So it can react with PCl5 to form alkaloid. And reaction involving only R group means aqueous group. When they're exposed to air and light, they form a peroxide which is unstable. It easily catches fire. Then if you take ESR reaction, in all the ESR reaction, the product is same, ortho and para, sir. Ortho and para. So this is what the reaction I told you in ethers. The two important reaction. When ether reacts with HI, what will happen? This bond will break. The I will go to one group and the C will go to another group. Always remember this one. So what will happen this bond? I'll just clear it. When this bond breaks up, the iodine goes to one group. It becomes ether iodide. The hydrogen goes to another group. It becomes alcohol. So when there is a aromatic ether, breaking this bond is difficult. It is having a partial double bond character. So we can break this bond, and when you break this bond, I goes to CH3. CH3. So when ether having tertiary carbon atom, when ether having tertiary, this is tertiary. Attached how many carbon? 3 carbon. Then I always goes to tertiary carbon atom. What do you get then? So you get phenol plus. This is the compound, tertiary butyl iodide, we call it as. And in ESR reaction, as I told you, electrophilic substitution reaction. Example, nitration. Which is the electrophile here? NO2 plus. Where the NO2 will go? It will go to ortho and para. If this 1, 2, 3, 4. So which is the ortho? Ortho means 2, sir. Position is 2. Para means position is 4. Next one, sulfonation. What is sulfonation? Addition of SO3H group. So what we get? We get para-methoxy or ortho-methoxy benzene sulfuric acid. You get ortho and para product. Whenever ESR reaction takes place, you get ortho and para. Next one. So I think this is enough. You can just go through the slides, what I have given. These are all the reactions of ether I have given, and reactions of aromatic ether under ESR, it gives ortho and para products. So these are the tests to distinguish between primary, secondary, and tertiary alcohols. Next one. So this is again a chart what I made. Already we have discussed what are the reactions in alcohols. I told you 3 preparation from Renard reagent, from carbonic compounds, from hydrocarbons. What are the reaction? Cleavage of OH bond, cleavage of CO bond. This is due to entire alcohol group. So these are the reactions. In phenol, I told you 4 preparation. Main important is I told you cumene, diazonium salt, benzene, sulfonic acid, alloalkanes, alurines. Then mainly I told you acidic nature of phenols. Then I told you ESR reaction, mainly important. So by using this information, we can go to questions. These are about ethers. I told you, very important is this one, reaction of ether with HI. Practice all these things. I showed you 3 of the reactions, you practice other things. In ESR, again, all the products are what? Ortho and para. Ortho and para. When exposed to air and light, it becomes unstable, forms a peroxide. Next one. So shall we go to questions now? This is the question appeared in a NEET 2020. What may be the answer? Tell me, please put it in the chat box. What may be the answer? What will be the answer? In a chat box, you have to put the answer A, B, C, D. What it may be? I give you a clue. What is this? He only says reaction between acetone and the Renard reagent. I told you, if it is formaldehyde, you get primary. If it is any other aldehyde, secondary. Ketone, so tertiary alcohol, we get it. So what may be the option? Give me answer. I'm not able to see any. Vinod Kumar, C. We have Vinod Kumar, A. All of you should give answer, whether A, B, C, D. What may be the option? Anonymous attendee, please give me your name. All of you, please give your name. Don't put it like that. M16, M19. Very good. Sanjana, 3. Lalit, C. Sushmita, C. Very good. Very good. Very simple. It says acetone. No. Acetone means ketone. Acetone means ketone. That means I should get tertiary alcohol. Tertiary alcohol. That's what the answer is. Which is the tertiary alcohol? If you look at this one, he only says isopropyl, not possible. He only says secondary, not possible. He says iso. Iso means secondary. Here is the one, tertiary butyl alcohol. Yes, Purnima, B. Purnima also, secondary alcohol. Why secondary alcohol, Purnima? Why secondary alcohol, Purnima? It cannot be secondary. As I told you, look at here. He says acetone, no. No need to write equation. This is acetone. Acetone means what? Ketone. Ketone means I should get tertiary. Where is tertiary? This is what tertiary. He only says. Direct question is given. See. Very good. But many of you have mentioned it as C. So what may be the option? Yes, sir. C is the answer. Look at here. You can see that. What has happened? Acetone reacts with Grignard reagent. Tertiary butyl alcohol. And here he has given reaction and he's asking what is A? What is A? Just think about it. What is this molecule? We should understand. So this molecule is nothing but what? Cumene. And where we use cumene? To prepare phenol. So yes, this is a phenol. So what will happen? You're adding oxygen. Where this oxygen will go? Will attach to CH. What will happen? That CH becomes CO, peroxide linkage. And it will be like this. CH3 will be there. CH3 will be. And the over linkage is called as what? Peroxide linkage. Peroxide linkage we call it as. Where is the peroxide linkage? If you observe very carefully. So it looks like peroxide, but this is wrong. D is wrong. Here no peroxide only. B is wrong. And here peroxide is there, but the CH2OH. So this is also wrong. It should be C is the option. Sir, C should be the option. Let us check it out. I'll clear everything. Yes, sir. C is the answer. All these are appeared in NEET question. Again, the NEET question. Vapors of secondary alcohol is passed over heated copper at 573 Kelvin. The product formed is. Yeah, Prasad. Put it in chat box. What may be the answer? All of you. Very good. Very good. Aditya C. Pavitra C. Dirti C. Everybody got it. Very good. Okay, I'll go ahead. What is this? This is nothing but dehydrogenation, not hydration. Dehydrogenation. So what is dehydrogenation? When alcohol undergoes dehydrogenation in presence of copper at 573 Kelvin. So primary alcohol gives you aldehyde and secondary alcohol gives you ketone. And you only say secondary. When you say secondary, we should get ketone. What's the answer? C is the answer. What may be the answer? What is this reaction? Phenol reacts with chloroform. And forms, what is this? Salicylaldehyde. So it forms a salicylaldehyde. And we call it as Reimer-Tiemann reaction. Reimer-Tiemann reaction. So what is happening here? During this reaction, the CaCl3 and NaOH, they react. They react to form what? Sir, Na becomes NaCl. The OH becomes H2O. Then what will happen? You have removed one Cl. You have removed one Cl, which combines with Na to form NaCl. And the OH removes one hydrogen atom. So you're left with nothing but CCl2. And what is the valence of carbon? 4. So it is having a lone pair. And this carbon with lone pair of electron is called as carbene. How many chlorine is there? Sir, there are 2 chlorine. That's what it should be. Dichloro. Where is the dichlorocarbene? It should be D, sir. Next one. What may be the answer? The question looks very big, but it's very simple in nature. Can you give me an answer, all of you? What may be the answer? Where we have studied in preparation of phenol from cumene. What is cumene? We already told you isopropyl benzene. Isopropyl benzene. So what is isopropyl benzene? This propyl chloride, when reacts with benzene, that becomes cumene. Cumene undergoes oxidation and hydrolysis to form phenol plus acetone. Phenol plus acetone. So what is asking? What is PQR? So P is a cumene. Q should be phenol and acetone. What may be the option? So P should be cumene. Which is the cumene? This is not a cumene. It should be isopropyl benzene. So A cannot be. Then what may be the answer? Sir, if you look at the last option, sir, this can be answer. P is a what this is? This is cumene. And Q is a phenol. And this is acetone. Next one. Next one. Is it taking time? Wait a minute. What is the answer? Which one is the most acidic in nature? Can you give me an answer, all of you? Pavitra, Aditya, Lalit, last time you give an answer. Disha, quickly give answer. What is acidic? All right. So carboxylic group is more acidic than phenol. So phenol is more acidic than water. Water is more acidic than alcohol. Please remember it. All of you, give me option. Very good. Pavitra A, Aditya C, Dhriti C. What will be the option? So all of them are what? So phenols only. Sir, all of them are what? Phenols only. Then what do we have to look? We have to look for electron withdrawing group. Here is this withdrawing group. And wherever this withdrawing group is present, that is more acidic. Sir, CH3 is there means? No, it is electron donating group. This is less acidic. Less acidic. So who is more acidic? with electron withdrawing group. So B and C is the answer, sir. But there are how many NO2 group? 3 NO2 group. So C is the option. Next one. Reaction of phenol in chloroform in presence of dilute sodium hydroxide finally introduces which one of the following functional group? What may be the reaction? Reaction of a phenol with a chloroform. This is nothing but a Reimer-Tiemann reaction. So this is nothing but a Reimer-Tiemann reaction. Where phenol is converted into what? Sir, salicylaldehyde. Salicylaldehyde. So you get OH and CHO. So you're introducing which group? C group you are introducing, sir. Which of the following reaction can be used for the preparation of alkali? You're taking anhydrous zinc chloride. That means Lucas reagent. So this is nothing but Lucas test. What may be the option? In Lucas test, I told you, tertiary is more reactive than secondary and primary. So for tertiary, no catalyst is required. So for tertiary, catalyst is not required. It will take place. And here you're having already catalyst is there. So that will also take place. And here also catalyst is there. That will take place. Because both these are primary. Without catalyst, they will not take place. But catalyst is there. So take place. But second one, no, sir. It requires catalyst. So 1, 3, 4. 1, 3, 4. Where is that? Option D, sir. Next one. Which of the following will not be soluble in sodium hydrogen carbonate? That you have to do it. You have to give me. Everybody has to give me in. Very good. Give me the answer. Disha. Very good. C. C says. Lavanya. C. Next. Others has to give option. Just simply don't sit like that. Participate. He says which will not be soluble in sodium hydrogen carbonate. I'll give you a clue. Very simple it is. What is that simple, sir? Hydrogen carbonate is nothing but base. So who is soluble? A acid is soluble. Acid is soluble. Very good. Very good. Purnima C. Vidya C. SSR Purnima H. Sushmita C. Good. Very good. So acid is soluble. So what we have to find out? We have to find out less acidic. Then E is insoluble. E is insoluble. Who is more acidic? All these sulfonic acid, benzoic acid, they're all more acidic. So they are not the option. So phenols are less acidic. But among phenol, who is more acidic? A is more acidic. So that is not the possibility. Who is less soluble? The less soluble is orthonitrophenol because E is less acidic. Less acidic. Next one. In the following, what is C? It's called as multiple concept question. Dhriti, can you do it quickly? Very simple it is. Sushmita. Easily we can do it. I'll give it 2 minutes, 1 minute. Yeah, already we know when it reacts with KCN, it becomes a cyanide. And cyanide undergoes hydrolysis, they form carboxylic acid. When carboxylic acid is reduced, you get alcohol with the same number of carbon atom. Yes. What do you get? Sorry, ethyl alcohol we get. Next one. And these are all the reactions of phenol that already we have discussed it. Please go through it. I will send you later. And these are all the questions of what? Sir, CET. These are the questions of CET. So what is the answer? Whenever you say ONA, always remember sodium alkoxide, if it comes, it's a Williamson ether synthesis. The catalyst used in the preparation of an alkyl chloride by the action of dry HCl on an alcohol is, already told you, whenever you say HCl, it is a Lucas test. And Lucas test, who is more reactive? Tertiary is more reactive than secondary reactive. And which is the catalyst we use? We use zinc chloride, so option C. Next one. By heating phenol with chloroform alkali, it is converted into what? Again, already we have studied. So it's nothing but Reimer-Tiemann reaction. What do we get? Sir, we get salicylaldehyde. Next one. Denatured alcohol means what? I told you. What is denatured alcohol? Commercial alcohol. Sir, commercial alcohol is made unfit for drinking. Is made unfit for drinking. By adding what? Poison, methanol, and naphtha. So option is. Next one. Anisole can be prepared by the action of methyl iodide and sodium phenate. The reaction is called as what? I told you, whenever you use the word sodium phenate, what is sodium phenate? Sir, C6H5ONA. And I told you, whenever you get it like this, plus methyl iodide, it is nothing but Williamson ether synthesis. What may be the option? Option D, sir. Next one. Catalytic dehydrogenation of a primary alcohol gives you. What is dehydrogenation? I told you, removal of hydrogen. Primary alcohol, if you remove hydrogen, you get aldehyde. Secondary gives you ketone. So what we are supposed to get? Primary alcohol means, so we are supposed to get aldehyde. Among the following, which is least acidic? Yes, sir, least acidic. Already told you. The donating group decreases acidic nature. What are the groups present here? Sir, here NO2 group is there. Chlorine group is there. Cresol means you are having CH3. And CH3 is an electron donating group. Yes, sir, this decreases acidic nature. Decreases acidic. What may be the option? Sir, Cresol is the option. Yes, sir, D is the answer. The best method for the conversion of an alcohol into alkyl chloride is by treating with what? याद आಗುತ್ತೆ. What is alcohol? ROH. When we treat with SOCl2, what you get? Cl plus SO2 plus H2O. And what will happen? Sir, SO2 will escape. This is HCl will also escape. HCl will also escape. You get pure RCl. We call it as a Darson process. So what may be the option? So this we have studied in alkenes also. Glucose test is associated with alcohol, sir. One mole of organic compound A with a formula C3H8O reacts completely with 2 moles of HI to form X and Y. When Y is boiled with aqueous alkali, it forms Z. Z answers iodoform test. The compound A is. Please answer it. What may be the answer? First of all, what is iodoform test, sir? What is iodoform test? Any compound reacts with iodine and NaOH. That forms what? CHI3, yellow precipitate. Yellow precipitate. Then what do you get? You get RCOO-Na. Which will give iodoform test? Any compound having a CH3 group next to CO. R may be carbon or hydrogen in case of aldehyde ketone. If it is alcohol, it has to be CH3CHOH. CHOH R. R may be carbon or hydrogen. What is the compound A? What may be the option? Give me answer. What may be the compound? Let us see one by one. If C3H8O, if I take it as a ether, and if I treat with HI, what will happen? I always goes to a smaller group. This bond will break. We get CH3I plus, we get C2H5OH. So these are the two products, X and Y. And he says when Y is buried with aqueous alkali, it forms Z. It forms Z. Say, for example, if I bind CH3I, let's take this as a X and this as a Y. CH3I. Aqueous alkali 6. What is aqueous alkali? KOH. It becomes what? CH3OH. And he says it answers iodoform test. Is it possible? Is it possible? No, sir. It is not possible with CH3OH. Then what is happening here? He says with 2 moles of HI means excess. In case of excess, what will happen? C2H5OH also becomes C2H5I, and C2H5I becomes C2H5OH, and C2H5OH answers silver mirror test, this one iodoform test. I'll just put it like this. I'll take one board. I'll take a white chalk piece. Done. So what is happening here? Sir, CH3O C2H5. When you take HI in excess, so what will happen? They become C2H5. OH it becomes. Then in excess, it becomes C2H5I. And this becomes CH3I plus. Then what will happen? This with alkali means KOH. It becomes C2H5OH again. And C2H5 will answer this test. What is the C2H5? We can write it as CHOHR. Yes, sir, it will answer iodoform test. So what is the option? So option is methoxyethane. Next one. An oxygen-containing organic compound, upon oxidation, forms a carboxylic acid as the only organic compound with its molecular mass higher by 14 units. The organic compound is. What may be the organic compound? Is it aldehyde or is it a primary alcohol? What it may be? Let us understand this. So usually what will happen? Alcohol undergoes oxidation to form what? Aldehydes. And he says forms carboxylic acid. What is carboxylic acid? RCOH. And molecular mass increases by 14 units, he says. If I take one alcohol, let us say CH3CH2OH, and when it undergoes oxidation, it becomes what? CH3COH. So what I am doing here alcohol is oxidized to carboxylic acid. So one extra oxygen is there. Extra oxygen means molecular weight of oxygen is 16, atomic weight of oxygen is 16. And we have removed 2 hydrogen here. So minus 2. Yes, sir, it has increased by 14 times. What should be the answer? So primary alcohol is the answer. Phenol forms a tribromo derivative. What it is? Why it forms a tribromo derivative? Phenol undergoes bromination. It's a ESR reaction. It's a bromination, ESR reaction, we call it electrophilic substitution reaction. It all depends on this OH group, which is highly activating group. Highly activating group. When it is highly activating group, it gives you what product? Ortho and para. What is para? Position 4. What is ortho? 2 and 6. So when you get a compound, what will happen? All these positions, what is the position? 1, 2, 3, 4, 5, 6. So position 2 and 6, bromo we get. 4, we get bromo. This compound is called as 2, 4, 6 tribromo derivative. So this happens in bromine water. Next one. Identify B and D in the following compound. What is B and D? Already I've discussed with you. Acid catalyzed hydration. What is acid catalyzed hydration? So when you add water to it, what will happen? It becomes alcohol. CH3CH2OH. So it becomes an alcohol. So this is alcohol. B is the alcohol. What will happen from B? That's what you have to write. So B is what? Alcohol, CH3CH2OH. When it reacts with PBr3, OH is replaced by Br. Br. Then what is B and D is asking? B and D. So B is already told you, it's an alcohol. And here I have to get double bond. If I have to get double bond, this should be elimination reaction. Say elimination of I need alcoholic OH. Alcoholic OH. What should be the option? So it has to be B and D means it's ethanol and alcoholic OH. Ethanol and alcoholic OH. Yeah. Next one. The compound which gives stability immediately with Lucas reagent is, it has to be tertiary alcohol. It has to be tertiary alcohol. Which is tertiary alcohol? As it says, butanol 1-ol means it's a primary, so this is not the option. He says 2-ol, it has to be secondary, this is not the option. So this is the only option. And again, he says propane 1-ol means primary, this is. So this is also not the option. Only option is C. Check it out. Prop means what? 3 carbon atom, 2 methyl, CH3, 2 propanol. Yes, sir. And this carbon is attached. How many carbon? 3 carbon. And so this carbon becomes a tertiary. What is the option? Sir, C is the option. Next one. What is a power alcohol? Nowadays, we are mixing ethanol with petrol. How much we are mixing? We are mixing around a small amount of alcohol with petrol, around 20% with 80% petrol. That we call it as what? We call it as a power alcohol. So that we can save a lot of money. So what is the option? So it has to be B, second option. Next one. Identify C in the following reaction. Look at it. The same question is repeated already. I told you this is nothing but what? Cumene. This is nothing but cumene. And cumene gives you what? Cumene hydroperoxide. Then we get phenol plus acetone. Already we have discussed it. And other name of acetone is propanol. The option. Which of the following is strongly acidic? Which of the following is strongly acidic? Cresol means, I told what group will be there? CH3. Para means, again, CH2 group is there. CH2 group is there means they are less acidic. Why, sir? They are electron donating groups. Donating groups. So what is the option? A and C is the answer. But on A and C, in nitrophenol, we have NO2 group that becomes more acidic. Option 6. You get B molecule here. What may be the IUPAC name of B here? What may be the IUPAC name of B here? And what is this molecule? Sir, it's aldehyde. I told you, if it is a formaldehyde, you get primary. If it is any other aldehyde, you get secondary. So ketone means it is tertiary. So what is this? They are given aldehyde, but it is any other aldehyde. Any other aldehyde means it has to be secondary alcohol. And how many carbon is there? Just see. 1, 2, 3, 4 carbon is there. And here 1 carbon. That means your compound should have 5 carbons. What may be the option? Just check it out. What may be the options, sir? Let us take that molecule. Let us see what will happen. What is the molecule? CH3. CH3. Then you are having one ketone group. C double bond group. H. Sorry, did. When I add did not reagent, what will happen? This MgBr will attach to the oxygen atom and the CH3 will attack carbonyl covenant. So what do you get? CH3CCH3. Then this C combines with OMGBr and your CH3 will come here. H. When I hydrolyze it, what will happen? This OMGBr becomes OH. OH. If it becomes OH, what may be the name of the compound? 1, 2, 3, 4. So it should be butane to all. Butane to all. Plus, there's a one methyl group here. Where it is at third carbon, we are having a methyl group. So it should be 3 methyl butane to all. Next one. Yes, sir, option is right. What will be the major product here? When it reacts with the C6H4COCl, HCl and H combine to form what? HCl. The entire group adds there. What you are having here? C6H5CO. What is C6H5CO? You can write it like this. C6H5CO. Next, what will happen? This OH will combine. So you can write it as OC6H5. So what you got? You got ester. So this is the ester. And this we have to subject it to nitration. What is nitration? Addition of HNO3. This is called as nitration. So where the nitro group will go? Nitro group will go to those places where there is a more electron density. Because NO2 is electrophile. He loves electron. Where there is more electrons, he will go. And this is a electron withdrawing group. So NO2 group will not come to less electron density. They go to where there is more electrons. So here there is more electrons. So NO2 plus will go to and attach to C. So what will be the option? Sir, option yes, sir. Next one. Please do the next problem. Look at this one. Solve it. By the time I will. Find out what is the alcohol is. So how to find out what is the alcohol? We know that he says monohydric alcohol. What is monohydric? OH group. It gives you methane. How many cm cube? 112 cm cube. How much you have taken? 0.44 gram. And with PCC, the same alcohol gives a carbonyl compound. What is carbonyl? It may be aldehyde also, ketones also. But he says it will not answer it will answer Silomerer test. It gives you Silomerer with Taulin's reagent. That means it reacts with Taulin's reagent. When it reacts with Taulin's reagent, that means it is not a ketone. It is a aldehyde. When it is aldehyde, this should be primary alcohol. Primary alcohol. Then what may be the option? It should be primary alcohol. So which is the secondary? So this is secondary. So this is not the option. So this is secondary. So this is not the option. So which are primary? We are left with only B and D is the answer. Then how to find out, sir? Then how to find out? Then you have to use the calculation. Again, you have to remember a little bit of basic concepts of chemistry. Mole concept. 1 mole of alcohol gives you 1 mole of methane. 1 mole means how many cm cube? 22,400 cm cube. And once if you know the mole, that means you know the molecular weight also. So we know that molecular weight of that substance will give you how much? So 22,400 cm cube. But how much you got? 112 cm cube. From how many grams? So 0.44 grams. So then what is the molecular weight? Sir, molecular weight is equal to 0.44 into 22,400 divided by 112. How much it will be? 88, sir. So the molecular weight of a compound is 88. That we have to find out. Is it B or is it D? We have to find out. That is how we do it. Sir, how to analyze it? What is atomic molecular weight? Molecular weight is nothing but sum of atomic weight. Molecular weight is nothing but sum of atomic weight. Atomic weight. What may be the option? So let us find out how much it is. I will take another color. Brown I will take. So there are, let us check with B. How many carbon atoms? So there are 5 carbon. 5 carbon means 5 into 12. So 60. Then 1 oxygen is there. Oxygen means 16. Then hydrogen is there. How many? So 3 is 9. 9 plus 2, 11 plus 12. So 12 hydrogen is there. 12 hydrogen. How much it counts? We are supposed to get 80. What may be the option? So the option is B, sir. Option is B. because the total molecular weight is how much? So it is 80. 88. So option is B. So the total molecular weight is 88. So option is B. Next, we'll move on to other one. Arrange the following compound in the increasing order of their acidic strength. Increasing order of their acidic strength. I told you cresol means there will be a CH3, so it will be less. So chloro and nitro is the withdrawing group. But I told you nitro is more stronger than chloro. So 1 is more than. So 4. 4 is more than 3. 3 is more than 2. But this is he says increasing order. Then we can write it like this. Second is less than third. So third is less than 4. 4 is less than 1, sir. We can write it like this. Which is the option? Sir, last option. Towards good, sir. Last option. Next one. What are Z here? What is a Z here? He says ethanol reacts with PCl5. What is ethanol? So CH3CH2OH. Then it reacts with PCl5. So it becomes CH3CH2Cl. Alcoholic KOH means what? So it's the elimination reaction. Elimination. What do you eliminate? You eliminate HX. So you remove hydrogen, you remove halogen. Then what do you get? So we end up getting CH3, sorry, CH2, double bond CH2. CH2. Then you are adding water here. What is water? You are adding OH minus ion. That becomes our CH3CH2OH. It becomes alcohol. Just a minute. My laptop is low on battery. Just a minute, I'll charge it. Ravi sir, you are there?
Yes, sir. Yes, sir. I'm there.
Just a minute. My laptop charger, I will take it.
Okay, sir. Okay.
One minute.
Dear students, just 2 minutes. Sir will be back. If you have any query, you can put in Q&A. Will be reply. And I had mentioned in chat my name and my mobile number. And Mr. Bagli sir regularly will be there. He'll be joining us from Monday. Okay. If you have any query, you can put in Q&A.
Student, this time also, as I told that yesterday class due to some technical problem we have cancelled. So that particular class will be happen on Sunday. Same time 4 to 8 it will be there. So this time it will be like Saturday, Sunday, both days will be the class will be there, and as usual Monday to Saturday your as per the timetable it will be there. So this particular Sunday you have the class 4 to 8, and that will be the physics class will be there. Please join that up.
Yeah, right. Can I continue, Manoj sir? Ravi sir?
Sir, yes, sir. Continue, sir.
So what I got here, sir, I got alcohol here. And this can be written as just like this in a bond line formula. So what is the option? Option D, sir. Next one. So this is from 2016 KCET. Which of the following compound is most acidic? I told you, if CH3 is there, it's electron donating group. So it decreases acidic nature. NO2 is a withdrawing group. So it increases acidic nature. So option is C. Option C. So like this, many questions are there that we can take up later. I'll go to, look at here. In 2017 also, same kind of questions regarding acidic nature of phenols. Again, see, cresol means I told you, it will be a CH3. So it is less. Nitro group, so it is more acidic. More acidic. What is the true order he says? So this is not the option because it's less. Cresol should come first, then phenol, then orthonitrophenol. B is the option. Let us check. Is it B? Yes, sir. B is the answer. So we will take up these questions a little bit later. This is very interesting. Sir, this is in 2019. How to do this? I told you, lesser the pKa, that means more acidic. Sir, if pKa is more, that means it is less acidic. So who is more here in this? So picric acid is having a more acidic nature. Why, sir? It is having 3 NO2 group. It's a 2,4,6 trinitrophenol. So more acidic. Picric acid is more acidic. More acidic means it should have a low pKa value. Which is the lowest pKa value here? 0.78. It should be 0.78, sir. That means D should match with 2. Okay. Then let us go to ethanol. So what is ethanol? Ethanol is less acidic. So ethanol is less acidic. Less acidic means you should have more pKa. Which is the more pKa? 16, sir. Now what is the option? So it should be 1. C should be 1. That is the only option. Sir, option is A. So which of the following can be used to test the acidic nature of ethanol in 2019? Anybody, I told you, reacts with sodium metal is acidic in nature. Sir, alcohol? Yes, he reacts with sodium metal, acidic in nature. Phenol, he reacts with sodium metal, acidic in nature. Carboxylic acid reacts with sodium metal, is acidic in nature. So this metal can be used to indicate acidic nature of alcohol. Let us check it out. Is it right? Yes, sir. Is the right thing. The steps involved in the conversion of propane 2-ol to propane 1-ol. Last year they asked 2020. It's very easy. So what I've done, first I treated with PCl5. The OH is replaced by Cl. It's a NSR reaction, nucleophilic substitution. Then I do elimination, removal of halogen and hydrogen. I got alkene. I do hydroboration oxidation. What is this? This follows anti-Marconi Coff rule. What is anti-Marconi Coff rule? The OH minus attaches to that carbon having more hydrogen atom. So from one propane to all, I got propane 1R. What is the difference? The position, the 2 and the 1. So they're called as what? How I got it? With PCl5, with alcoholic KOH, with hydroboration oxidation. There it is. Sorry, eating with PCl5, alcoholic KOH, hydroboration oxidation. Option B. Which of the following on eating gives ether as a major product? Ether as a major product. What is this reaction? Sir, Williamson ether synthesis. Williamson ether synthesis. And what is Williamson ether synthesis? Alkyl halide reacts with alkoxide. I write it here. RCl reacts with RONA to form what? Ethers. And always remember, the R shell should be primary. It cannot be secondary. It cannot be tertiary. But here, look at here. Here in R, they are given tertiary. So R cannot be. Sir, R cannot be. Yes, cannot be. PQ, yes, sir, this is primary. This is also primary. So P and Q, where is the P and Q? Sir, option C. P and Q is possible. Let us see, check it out, whether is it right or wrong. Yes, sir, option C, P and Q is possible. Let us go to one more chapter, aldehydes and ketones. So this is the second part of the organic compound containing oxygen. This is the second part of it. What is aldehyde? Any compound having general formula. I know that RCHO is an aldehyde. They have a general formula. All carbonyl compounds have a general formula CnH2NO. Why they called as carbonyl? They have a CO group. CO group. And their carbon is, remember, sp2 hybridized. And they bind with p orbital of oxygen. They form a pi bond. And the bond length in ketone is 1.23, whereas in alkene it is a 1.34. But CO bond is having more energy. Remember this. They have a large dipole moment because oxygen is more electronegative in nature. So these are the preparation of both aldehydes and ketones. So how to prepare it? Say if you take alcohol and if you subject it to oxidation, you get aldehydes and ketones. Alcohol, if you subject it to controlled oxidation with PCC, again you get aldehydes and ketones. Again you take alcohol, subject it to dehydrogenation, removal of hydrogen, you get aldehydes and ketones. You oxidize by iodide, you get aldehydes and ketones. If you subject alkene to ozonolysis, you get what? Ozonide. Then break it by using water, you get aldehydes and ketones. From geminal dialide, treating with aqueous KOH, you get aldehydes and ketones. By adding sulfuric acid in terms of mercuric salt, you get aldehydes and ketones. Then by using hydroboration oxidation, you get aldehydes and ketones. By heating calcium salts, you get aldehydes and ketones. By oxidizing by using manganese oxide, carboxylic acid, you get aldehydes and ketones. So on this method, we get both aldehydes as well as ketones. Let us take reaction where we get only aldehydes. We get only aldehydes. Sir, when I treat RCOR, what is this? Yes, sir. And if I reduce it by using Dibal, diisobutyl aluminum hydride, then you get only aldehyde. If cyanide is reduced in presence of Dibal, you get only aldehyde. RCN is reduced in presence of stannous chloride, Stephen's reaction. Sir, only aldehyde. RCOCl, when reduced by vanadium, Rosenman reduction. Sir, we get only aldehydes. Where we get ketones? So when the cyanide reacts with RNGX, we get ketones. When acetaldehyde reacts with alkyl chlorides, R2CD, we get alkyl cadmium, we get ketones. Treadle-Craft acylation, sir, we get ketones. We get ketones. Preparation of only benzaldehyde. Sir, Gutterman reaction. From benzene, we can get only benzaldehyde. When benzene reacts with SCN and HCl in terms of AlCl3, benzaldehyde. Sir, when toluene is subjected to oxidation by using CrO3, we get benzaldehyde. When toluene subjected to oxidation by using chromyl chloride, we get benzaldehyde. When toluene subjected to side chain chlorination or free radical substitution reaction, we get benzaldehyde. So, a few important things here. Remember this one. Formaldehyde we cannot prepare by Rosenman reduction. And always I use dialkyl cadmium, R2CD. Remember, are less reactive than Grignard reagent. Hence, they react with acyl chloride to form ketones. And due to polarity of the CO group, they undergo nucleophilic addition reaction. Who is more reactive for this nucleophilic addition reaction? Always remember, aldehyde is more than ketone. Among aldehyde, one who is having lesser carbon is more reactive. Because as the number of carbon atom increases, steric effect increases. Plus effect increases. The reactivity decreases. And ketones cannot be prepared by the action of Grignard reagent with acid derivatives because it gives a alcohol. So we cannot prepare Grignard reagent by ketones by using a Grignard reagent with acid derivatives. So what are the reactions we have to study in aldehydes and ketone? Mainly nucleophilic addition reaction. Which are those? Reaction with HCN, reaction with sodium bisulfite, reaction with alcohol, and reaction with Grignard reagent. Just these 4 reactions is enough for us. So when it reacts with sodium bisulfite, it gives you white crystal. Remember this one. When it reacts with HCN, sir, it gives cyanohydrin. Cyanohydrin, please remember. So when it reacts with alcohol, it gives you emisitol. One more alcohol, acetol. If it is a ketone, we get ketol. Ketol. With RMGXR, it gives alcohol. It gives you alcohol. Then one more reaction is there. What is that? So nucleophilic addition elimination reaction. Or we can also call it as reaction with ammonia and its derivatives. And derivatives. 7 reactions are there. Please practice it. Which are the 7 reactions? Here they are given. Here Z is equal to H. This is NH2H. H means ammonia. R means amine, RNH2. OH means NH2OH, hydroxylamine, hydrazine, like this. Here, the Z may be H, R, OH, NH2, this group. What is this group? Phenyl-hydrazine. This is semicarbazide. This is 2,4-DNP. In all this reaction, what is the reaction happening? Water is eliminated. Sir, one water molecule is eliminated. Sir, show one reaction. I write here. CH3, CHO. say reacts with NH2OH, hydroxylamine. So what will happen? One water molecule is eliminated. Which water molecule? This H2O combines with O to form what? So what is remaining then? CH3. CH double bond NOH. This is called as oxime. We also call it as acetaldoxime. In all this reaction, in all these 7, it's a removal of water. Ravi Verma sir, we have to leave for break.
Oh, okay, sir. Okay, sir. Another 2 minutes is there.
Okay, we'll just continue this slide then. Huh?
Yes, sir. Please, sir. Please, sir.
Then, so aldehyde ketones gives alloforum reaction. Already I've studied. What is alloforum? Formation of CHI3, yellow precipitate. Sir, who will give this reaction? Remember this one. Anyone having this formula, RCOCH3, where R may be carbon or hydrogen. In case of alcohol, sir, anybody who is having the general formula RCHOHCH3 in case of alcohol, where R may be carbon or hydrogen. Remember this one. So what should be there? Next to COCH2 group is there. Then only they give iodoform reaction. What will happen? They react with iodine and NaOH to form CHI3. It's an iodoform, but most frequently asked is iodoform. Yellow precipitate. We come across this in alcohol, aldehydes, ketones, alkyls. So what is aldol reaction? This is given by aldehydes having alpha hydrogen. What is alpha? So this is a functional group. Adru pakka irade alpha. The next one is alpha. The hydrogen is alpha hydrogen. If anybody is having alpha hydrogen, they give this reaction. Say for example here ketone. So this is the functional group. So this is alpha carbon. And hydrogen attached to is called as a what? Alpha hydrogen. Alpha hydrogen. So they give this reaction. What is aldol? It will be having a OH also, aldol also. That's why aldol. Or ketol. Ketone also, alpha. Usually, upon eating, they lose water, and what they get? You get alpha, beta, unsaturated aldehyde, or alpha, beta, unsaturated ketone. And this reaction takes place only in terms of dilute NaOH, remember, not strong NaOH.
So now can we go to break?
Yes, we'll take a break.
Okay, my dear students, now it will be a break for 15 minutes. Early, like 6:05 class starts. I request you to log in 6:03 or 6:04 before that. Thank you.
Sir, shall I log out and come back, or shall it be like this only?
Yes, sir. Yes, sir. Yes, sir. You can log out and you can again join.
Okay. Or let it be like this only, because you don't want to take a risk.
Yeah. Be there like that.
Let it be here like this one.
Welcome to the School of Engineering at Dayanand Sagar University, main campus, Harohaldi, Kanakpura Road, Bangalore. A place that values research, innovation, and creativity. Our industry-aligned curriculum offers a blend of theoretical knowledge, practical experience, academic projects, and internships for a rewarding career in engineering. With an interdisciplinary approach, you can explore your interests by selecting open electives. The on-campus innovation labs, led by professors of practice, provide immersive learning and expertise to find the best solutions to real industry problems and give a different dimension to the students' mini and major academic projects. Our Center for Entrepreneurship supports startup opportunities and provides a perfect platform to launch your next big idea into successful ventures. We also prepare you for advanced studies in the latest futuristic technologies. Our BTech programs offer the perfect combination of academic rigor and functional experience in this ever-evolving technological landscape of the future. Experience a whole new world of academic excellence in a global environment. Dayanand Sagar University. Live the dream.
Students, as the results, PUC results are out. So hope all of you have seen your result. The students who are planning for engineering, if they like to know more detail about the computer science, if you are like to attend this webinar, 26th, we are conducting this webinar for the computer science, exclusively for the computer science, and you can get the detailed information about the computer science engineering, and also like the specialization also, and the job opportunity, and how the market is looking for next to the 4 years, what will be the scenario. So all this information you can get, so that you can have a clarity, and you can decide your career, and you can decide your BTech branch also for that further. So these are the information. It will be all the experts committee will be there. Our Dr. KNB Murthy, the Vice Chancellor of Dayanand Sagar University, he is going to address to all the students, and also Dr. Pradeep V. Desai is the co-founder and CBO of the healthcare sector, and he is also will be the one of the panelists. And Dr. Rakesh Raghavendra, who is the architect and AMD for the AMD Bangalore, and worked with HP and Adobe Systems. And Professor Arvind Sinwas is one of the panelist member who having the 30 years experience in TCS. And our CMO, Mr. Srinivas Sindhe also will be there, the board director, who is going to host this webinar. So this webinar will be 26th, 11 o'clock to 12:30. So if you can attend, definitely you will get the more detail about the computer science engineering. Whichever the college or whichever the university you can choose, you will get the clarity about the computer science engineering and the specializations. And we have another webinar on 27th. We have another webinar which will be same 11 to 12:30. That is exclusively for the electronic communication, electronic communication engineering. Those students who are looking for electronic communication engineering, for them we are keeping another webinar on 27th. So they can get all the detailed information about the VLSI technology, artificial intelligence, all this information they are going to get on 27th. So those students who are interested, they can register and they can attend 11 to 12:30, 1.5 hours this particular webinar, morning time. Definitely, because the students, as your results are out, you must have the plan for the various careers and various engineering branches you are looking for. So you will get the clarity on this. Don't miss this webinar. You please attend. So you will definitely will get the very good input for this. Thank you. Students, please rejoin. We'll start the class.
Ravi Shankar sir, are you there, sir?
Shall we start then?
Yes, sir. Please go ahead, sir.
So after this reaction, so three reactions are over. One is nucleophilic addition elimination, allophora, aldol condensation we call it. Then important is Canizarus reaction. So what is a Canizarus reaction? This reaction is given by those aldehyde which do not have alpha hydrogenate. Very, very important. No alpha hydrogenate. Like benzaldehyde. And they should react with concentrated alkali. They undergo disproportionate. What is disproportionate? They undergo both oxidation as well as reduction. If they undergo reduction, say if they undergo reduction, what will happen? They get alcohol. So you end up getting alcohol. Like this. Formaldehyde gives you alcohol. If they undergo oxidation, same molecule, if they undergo oxidation, so they give you carboxylic acid. Salts they give, salts. This kind of reaction where one of the reactant undergoes both oxidation reduction is called as what? Disproportionate reaction. And this we call it as a Canizarus reaction. This take place in presence of 50% concentrated base, remember. But if this is around 10%, it is an aldol. But for aldol, we require alpha hydrogen atom. What is the next one, sir? Oxidation reactions. What are the oxidation reactions? So whenever aldehyde undergoes oxidation, they form carboxylic acids. First point. Next point is that you can take anything, sir. You can take strong oxidizing agent also. Sir, you can take weak oxidizing agent also. Anything you can take. Which are weak? Say Tollin's reagent and filling solution, they are all weak, sir. These are all weak oxidizing agent. For aldehyde, that is enough. But for ketone to get oxidized, sir, if we have to oxidize ketone to carboxylic acid, then I cannot use weak, I have to use strong. So ketones will not react with Tollin's reagent and Pauling solution. Ketone, remember, reacts only with strong oxidizing agent like KMNO4, potassium dichromate, sulfuric acid, KOH like that. And also, here you get same number of carbon atom. When aldehyde undergoes oxidation, you get same number of carbon atom. But here it is always less carbon. Always less carbon. This is the second point. Third point is how aldehydes react with Tollin's reagent. What is Tollin's reagent? Ammoniacal silver nitrate. There you are having silver in the form of ion. And your aldehyde will reduce the ion into what? Atom. It becomes a silver mirror. Pauling test. It is given by aliphatic aldehyde. Remember this one. What is Pauling solution? Pauling solution is nothing but NaOH and copper sulfate. So NaOH and copper sulfate, where copper is present in the cupric form, is reduced into cuprous oxide, which is a red precipitate. So these 3 points I want you to remember in oxidation reactions. So aldehydes can be reduced by oxidized by only strong, is reduced by both strong and weak. Ketones are reduced only by strong, oxidized only by strong. And how aldehyde react with Tollin's test and Pauling test. Next we'll go. Reduction reaction. So whenever alcohol is reduced, you end up getting aldehydes. You can use any kind of a reducing agent. And if you want to reduce aldehydes into hydrocarbon, and if you use hydrazine, it is called as Wolff-Kishner reduction. And if you convert it into alkane by using zinc amalgam and HCl, it is called as Clemenson's reduction. You can also convert it into alkane by using red phosphorus and HI. Red phosphorus and HI. Remember this one. Then alloform reaction, already told you, is possible only with CH3CHOH and CH3CO group. What is alloform? Remember, iodoform reaction. And aldehydes and ketones can be reduced by sodium borohydride. Whereas these are all derivatives of carboxylic acid. They are reduced only by lithium aluminum hydride. Not by NaBH4. Remember, not by NaBH4. NaBH4 can reduce only aldehydes and ketones. Not carboxylic acid or derivatives of carboxylic acids. Next, we'll move on to carboxylic acids. Okay, what are carboxylic acid? Any compound having general formula RCOH is called as what? Carboxylic acid. What are the derivatives? 4 derivatives, where if OH is replaced by halogen, we call it as a acyl halide. If you replace OH with NH2, we call it as amide. And if you are having a RCOO linkage, we call it as ester. And if you remove water, you get RCO twice O. We call it as an anhydride. So these are the 4 derivatives. Remember this one. And among this derivative, the boiling point, amide is more. Remember this one. And the boiling point of this acid chloride means this one, is very lower. Why? There is no hydrogen bond. And among the reactivity, acyl halides are more reactive. Remember this one, because the CO is a withdrawing group. The reactivity decreases due to leaving group becomes unstable and this basicity increases. This is more basic, so this is less reactive. Less reactive. So these are the few preparation of carboxylic acids. If you take, we can prepare it from what? Alcohol. How we can prepare? By oxidation. This is cyanide. How we can prepare? By hydrolysis. You are having primary alcohol by oxidation, again, chromium oxide. You are having urea by hydrolysis. You can get carboxylic acids. You are having esters by hydrolysis. You can get carboxylic acids. You are having acyl halide by hydrolysis. You can get carboxylic acid. You are having anhydride. These are called as anhydride. By hydrolysis, you can get carboxylic acid. By treating, what is this? Trichloroethane. By reacting with aqueous KOH, we can get aldehydes. Alloform test. What is this molecule? Acetone. So acetone reacts with NaOH and iodine to form carboxylic acid. Grignard reagent reacts with carbon dioxide, forms carboxylic acids. So these are the few methods of preparing carboxylic acids. Let us take some questions on this one. What are the questions? This is from Casey. In the reaction, RX reacts with KCN to form A, and A reacts with dilute HCl to form B. The product B is. What is the product B? E says dilute. Dilute means lot of water. That means it's nothing but hydrolysis. So when Rx reacts with KCN, it forms what? It gives you RCN, sir. And that you want to break it by using what? Water. You want to take water. Let me take 2 water molecules. What will happen? So the CN bond breaks here. Nitrogen combines with hydrogen, hydrogen, and hydrogen to form what? Ammonia. Ammonia. So what is remaining now? Now what is remaining is R. COOH. So carboxylic acid is what? So what we get? So we get C. Carboxylic acids. Next one. Which of the following compound would not liberate carbon dioxide when treated with sodium bicarbonate? What will happen? This can be used as a test for weak acids and strong acid. What do you mean by that? That means weak acid cannot liberate. So not liberate carbon dioxide. So strong? Yes, they liberate carbon dioxide. So then which are these strong? All these carboxylic acid, those we are having COH group, those who are having COH group, so they're all strong. So they are not the option then. They are not the option. So who is weak? So phenol is a weak here. So that is the option. When a mixture of calcium benzoate and calcium acetate is tri-distilled, the resulting compound is. What will happen to the resulting compound? Write the structure, all of you, and give me answer. Put it in chat box. Put option. Whatever you think, right? A, B, C, D, whatever maybe you think. Aditya, A. What about others? I give you shortcut. First you try. What about others? Everybody has to try. I will show you how to do it. I'll give you a shortcut. I will explain to you. But you have to give me options. All of you should give. Tell me whether it is A, B, C, D option. Vidya, A. Bhageshri, B. Bhavna, A. Others, what about others? I want all of them. All of them should give one option. I don't know. I will do it. I will give you a complete idea how to do it. Very good. Lalit, A. Sarvesh, A. A. Sarvesh, A. Okay, good. I'm waiting for everybody. All of you should put a option. Bhageshri, B. Pranati, A. Now, waiting for all of you. Very good, very good. Sushmita. Okay, Anya, B. Sushmita, A. Very good, very good. Satya, Sai, Prasad, A. What is this one? How to do it, sir? This all depends on whether you are having, I will take one board. I will take a what color board? I will take a brown color board. I will take a white chalk piece. Sir, if you are having a calcium format, always remember, if you are having calcium format, what is this one? Sir, calcium format. If you eat it, you always end up getting what? Aldehydes. Remember this one. Very simple. If calcium format is not there, so calcium format is not there. Not there. Definitely you're going to get ketone. For example, if I take sir calcium format, you eat it, you end up getting formaldehyde plus calcium carbonate. Sir, if I take calcium format plus calcium acetaldehyde, calcium acetate. What is calcium acetate? CH3COO twice here. Look at here. I have not taken only calcium acetate. I have taken both calcium acetate and calcium format. You substitute eating, you end up getting aldehyde only. You get acetaldehyde. So this is the difference. Remember this. And if I take only calcium acetate, look at here. I will not take calcium format. And if I eat it, I end up getting ketone. Ketone. Plus calcium carbonate. Everywhere you get calcium carbonate. Plus calcium carbonate. Like this, if I take calcium acetate plus calcium benzoate, what is benzoate? C6H5, COO twice here, calcium benzoate. And if I eat it, since calcium format is not there, you get ketone only. What kind of ketone you get? There will be one benzene ring and there will be a COCH3 group. What is COCH3 group? So ketone, what kind of ketone this is? Acetophenone, we call it. Acetophenone. So just take a screenshot. So if this is very important, if calcium format, remember this one, if calcium format is there, you'll end up getting aldehyde. If calcium format is not there, you're going to get ketones. Take a screenshot, I'll clear it. So this is how it takes place. So calcium acetate and calcium benzoate. So calcium format is not there. You'll end up getting ketone. So when ketone, this is not the option. So this cannot be the option. So either this one or this one. Since we are taking benzene and acetaldehyde, it has to be acetophenone. If only you have taken calcium benzoate, then you could have done benzophenone. Which of the following does not give benzoic acid? This is KCET 2006. All these things, no. If I don't mention need, that all this means these are all previous KCET papers. That's why I told you, all our sessions, no, please don't miss it. We'll be discussing all the relevant questions and also the question which has appeared in PYQ, previous year question papers. Next. Which of the following does not give benzoic acid on hydrolysis? Already I told you, If cyanide is there, cyanide always gives you on hydrolysis, gives you carboxylic acid. So don't worry, that gives you carboxylic acid. Benzoyl is a derivative. I told you RCOCl. They on hydrolysis gives you RCOH. Benzoate ester is a derivative. They upon hydrolysis gives you carboxylic acid. Carboxylic acid. So what will not give? Sir, benzyl chloride will not give, sir. That is the option. Why? What is benzyl chloride? Sir, where to the side chain, the Cl is attached. Side chain Cl is attached, sir. That will not give. Why? What will happen if I subject it to hydrolysis? Sir, it will give you alcohol. This, upon oxidation or with hydrolysis, you will end up getting OH group there instead of Cl. OH. So option A is the right one, sir. Yes, option that C is the right one. Benzyl chloride is the right one. The reagent used in Clemenson's reduction is, this is in KCET 2007. All these name reaction, no, don't leave it. All reduction name reactions. Which are the name reactions? Look at it. We have 4 reduction reactions. What is that? One is Rosenman reduction, then Stephen's reduction, then Clemenson's reduction, then Wolff-Kishner reduction. So remember, all these are very important. So what is the Rosenman reduction? We use their palladium. Stephen, so we use stannous chloride and HCl. Clemenson's, so we use zinc amalgam and HCl. Wolff-Kishner, so we use hydrazine. So like this, you make a short notes of everything. Just make a reagent list. Over, you get an idea. So what is the option then? Zinc amalgam and HCl. What do you mean by that? That means, sir, all the aldehydes will be converted into alkanes, all right, or we can say hydrocarbons. Next one. Write the reaction, all of you, and tell me what is the option. The reaction ಬರ್ಸಿದ್ದೀನಿ ನಾನು. What is the option? What is hydroxylamine? NH2OH. I told you, when it reacts with NH2OH, it has to be oxime. If it reacts with NH2NH2, then you get hydrazone. So option is B, sir. The compound on dehydrogenation gives a ketone. The original compound is. And he only says dehydrogenation. Look at here. That's why I told you. Dehydrogenation, we studied in alcohol also. And we are studying in aldehydes and ketones. So look at here. Both the places we are studying the same thing. What is dehydrogenation? Removal of hydrogen. By using what? Copper at 573 Kelvin. What will happen? So primary alcohol gives you aldehyde. But secondary alcohol gives you ketone. Gives a ketone. So you want ketone? No, you have to take secondary alcohol. What is secondary alcohol? Sir, option B. Next one. Which of the following organic compound answers both iodoform test and Fowling test? Read the reaction. याद होता है. Already I told you. Who will answer Fowling test? What is Fowling solution? Sir, only aldehydes will answer. And who will answer iodoform test? Only those compounds which are having the structure CH3COR, or those structure which are having CH3CHOH. ಈ ತರ ಇದ್ರೆ ಮಾತ್ರ iodoform. And R may be carbon or hydrogen, R may be carbon or hydrogen. One by one we'll check. Methanol, what is methanol? Sir, CH3CHO. Methanol, what is methanol? Methanol means SCHO. SCHO. So there is only one carbon, sir. So this cannot be possible because minimum there should be 2 carbon. So propanon, what is propanon? Let us write the structure. CH3COCH3. Yes, sir. This will happen, sir. But propanon is a ketone. Ketone. It will not react with Fowling solution. So this is also not the option. Then what is the option? You are having 2 things. Ethanol and ethanol. What is ethanol? Alcohol. CH3CH2OH. Alcohol will not answer Fowling test. So alcohol will not answer, but they give iodoform test. They give iodoform, CH3 they give. Not Fowling test. Not Fowling test. So C cannot be. So what is remaining with? Ethanol. What is ethanol? CH3CH. What is CH3CH? We can write it like this. CH3CHO. See whether it satisfies our formula. Yes, sir. You are having CO group next to CH3. You are having CO group next to CH3. And this will give both iodoform as well as Fowling test. So answer is yes, sir. Take a screenshot. Next one. Take a screenshot if you want. Waxes are esters of what? What is alcohol? ROH. No, sir. Esters means what? You need to have a CO linkage. Glycerol means again OH group. These are alcohol and long chain fatty acids means they are separately only alcohol only. Glycerol and fatty acid. Glycerol is alcohol. Fatty acid is a carboxylic acid, and both will react to form ester. will form ester. So option E is here, there's a small change. This also you can include. Look at here. Alcohol and fatty acid. Here also is there. Fatty acid and alcohol. So both are there. Here the option you take B rather than A. My mistake. You can take B only. What is esters? Esters means both alcohol and carboxylic acid react to form what? Esters. Here what you are having? Here you are having fatty acid or COH. And alcohol means you are having ROH is there. I'll clear it and write. Sir, here you are having alcohol and here you are having COH. And both can react to form ester. Next one. So what will happen? When acetic acid reacts with lithium aluminate, copper and NaOH, and it forms a Z. So what is Z? Already you know, copper if you use 300 degrees Celsius, that means dehydrogenation, removal of hydrogen. And when you do dehydrogenation, you may get what? Aldehydes or you may get ketones. So when it reacts with NaOH, Z should be aldol or ketone. Then you can remove this one, D and A. D and C you can remove. So option is A or B. Then let us see. CH3COH. When it is reduced, I told you, you need a strong reducing agent. It becomes an alcohol with the same number of carbon atom. Same number of carbon atom. Then this undergoes dehydrogenation. Dehydrogenation. And you know that primary alcohol, when they undergo dehydrogenation, you get aldol. Aldehyde. When aldehyde reacts with dilute in NaOH, you get aldol. There should be, answer should be yes, sir. This is how it happens. Answer is A. The compound which is not formed during the dry distillation of a mixture of calcium formate and calcium acetate is, already I told you, this calcium formate it comes, that means you're going to get what? Aldehydes. But question is, compound which is not formed. So ketone is not formed. You get aldehyde. Ketone will not get. Ketone is not formed. Which is the ketone? There's only one option. So propanol. Propanol. You will not get propanol, sir. This is in KCT 2009. One more option is there. So propanol is also there. Option A is there. What we can take? Sir, only if you take calcium acetate. If you take only calcium acetate and subject it to distillation, you'll end up getting propanol also. So then, sir, let us remove this option. So this you will not get with by anybody. Propanol, you will not get it from anyone. Because, sir, only if you take calcium formate also, you get what? You get methanol. So you get methanol, is not possible. You may get propanol, is not possible. Sir, if you mix calcium acetate and calcium formate, you may get ethanol. So that is also not the answer. So option is A, sir. It has to be A. A is the answer. The organic compound X is oxidized by using acidified potassium dichromate. The product obtained reacts with phenylhydrazine but does not answer zero-error test. The possible structure of X is. When they give a statement question like this, just write it down, flowchart. You are having a X is subjected to oxidation with K2Cr2O7. The product obtained, this is a product, reacts with phenylhydrazine. Reacts with phenol. What is phenylhydrazine? C6H5, NHNH2. That means it can react with, it is an aldehyde or ketone. Then he says, no tolerance reagent, no slow mirror. No slow mirror means it should be ketone because aldehyde gives slow mirror. So it should be not aldehyde, it's a ketone. Then what is the possible structure of X? If it is a ketone, then X should be secondary alcohol. X should be secondary alcohol. What is the secondary alcohol? What is the option? So it should, when I say alcohol, it cannot be aldehyde, it cannot be ketone. So there are only two options. But D is also not possible, sir. Why? So this is a primary alcohol. So only option is B, sir. Only option B. Why it is secondary? Let us write it down. CH3 twice you say. CH, CH3, OH, OH is attached to a carbon, which in turn attached to how many carbon? Two carbons. So this is a secondary. So alcohol is a secondary. Take a screenshot. The reaction involved in the oil of wintergreen test when salicylic acid reacts with sulfuric acid upon heating. And the product is treated with sodium carbonate solution. The missing reagent in the above reaction is. What may be the action? Oil of wintergreen test. I'll give you a clue. It's a methyl salicylate. Is ester? Ester means salicylic acid is carboxylic acid. So what is missing? Sir, alcohol is missing. Alcohol is missing. What is the alcohol missing? There are two alcohol. Of course, A cannot be, D cannot be. So answer is B and C. Then you have to remember, what is this molecule? I love wintergreen is methyl salicylate. What is methyl salicylate? This is salicylic acid, OH, COH. This reacts with CH3. This is methyl salicylate. So what you're adding here? So you're adding here one CH3, COCH3 group, which comes from alcohol, which is having same number of carbon atoms, CH3OH. Then it should be option C, sir. Option C. What will be the answer? Let us check it out. Yes, sir. Option C is the answer. Methyl salicylate. Next, the compound which forms acetaldehyde when heated with dilute NaOH is what may be the compound? What do you have to get? Acetaldehyde you have to get. I told you, we can get aldehydes by geminal dialytes. So we can get it from geminal dialytes. What is geminal dialytes? Where two halogen attached to same carbon. There are two kinds of geminal dialytes, terminal and non-terminal. What is the terminal geminal dialytes? Where you are having a halogen attached to same carbon, but at the end or at the starting. Like this. Non-terminal means what? In between. They are not at the end or starting. They are in between. They are non-terminal. And non-terminal, always remember, upon hydrolysis gives you ketone. Whereas terminal upon hydrolysis gives you aldehyde. And he says aldehyde. Then it should be terminal geminal dialytes. What is terminal? C cannot be. 1-chloro, it's not a geminal dialyte. Trichloro, it is not a geminal. So only one option. So D is the answer. 1, 1 dichloroethane. Let's check how you get this one. How you get this particular aldehyde? 1, 1 dichloroethane. Let us take it. One, 1 dichloroethane, CH3, CHCl, Cl. It is 1, 1 dichloroethane. And if you treat with aqueous NaOH, what will happen? OH will replace chlorine. When it replaces chlorine, what do you get? CH3H, OH, we get. And we told you in chemistry, 2 OH cannot attach to same carbon atom. They become unstable. When they become unstable, one H and OH will combine to form water. So it becomes a water. So what is remaining then? So CH3, CHO is what remaining? Yes, we get aldehydes. So we get aldehydes. So only we have to take terminal geminal dilate, sir. We get aldehyde. Next one. So option is D. D is the answer, sir. Next one. The compound obtained when acetaldehyde reacts with dilute aqueous sodium hydroxide exhibit. What is acetaldehyde? What kind of isomerism it exhibits? We don't know. Let us check it out. He says acetaldehyde. What is acetaldehyde? CH3CHO. And when he says dilute, it may be aldol condensation. What is aldol condensation? Then I write like this structure. I just undo it. I can write it like this. CHO can be written as C double bond O H. Two molecules will combine in presence of the dilute NaOH. Then what will happen? This one hydrogen is given to this oxygen. What do you get? CH3, C, you get OH. You get H, CH2, CHO. And this is the aldol. And I told you, this upon eating little bit, it loses water from where? From here, sir. This OH and the 1H will be lost as what? Water. So what is remaining? So what is remaining is CH3, CH, double bond, CH, CHO. And when you get compound like this, any compound having carbon-carbon double bond will show geometrical isomerism. What is geometrical isomerism? There are two types, cis and trans. If light group is on same side, we call it as a cis. If they are on opposite side, we call it as a trans. So this will exhibit geometrical isomerism, sir. What is geometrical isomerism? They differ in configuration around carbon-carbon double bond. What is geometrical isomerism? So the differ in configuration around carbon-carbon double. That is called a geometrical isomerism. So what is the option then? So geometrical isomerism should come. Where is the option? Let us see. What may be the option there? Is it optical or geometric? Both cannot be possible. What may be the option? So this is what I have written. If you look at this molecule at the center, first we got this, no? This is having a carbon atom in which 4 different groups are present. This is one different group, 1, 2 different group, third different group, and this is a different group. Then this carbon atom is, we call it as chiral. Chiral means it shows optical activity. Optical activity. So if you take up to this point, we can say optical isomerism. If you take alpha beta, geometrical isomerism. Since he has not given heating, we will remove this part. This part let us not take. Then it is only, sir, optical isomerism. Only optical isomerism. What is the option? B is the option, sir. And which is the chiral carbon atom? So this is the chiral carbon atom. The C is the chiral carbon atom. The correct sequence of steps involved in the mechanism of Canizarus reaction is. What is the Canizarus reaction? A aldehyde having no alpha hydrogen. So combines with alkali. What is alkali? NaOH to form what? Alcohol plus salt. Then what is the first step in mechanism? The correct sequence of things are how it happens. So first, a nucleophile should attack it. That means A is the answer, sir. This is how it happens. So which is the nucleophile? The NaOH, what you have taken now? The OH minus will attack it. That is the first step. Then there is something called as hydride ion transfer. Then there is again what? Transfer of H plus. That means option A, sir. Benzaldehyde and acetone can be best distinguished using acetone is what? Ketone. And this is aldehyde. What we can use to distinguish it? And we know that ketones will not react with the weak oxidizing agent. Which is the weak oxidizing agent? Sir, Tollens reagent. Tollens reagent is a weak oxidizing agent. And ketones will not react. So they can be separated by Tollens reagent. Formic acid is stronger acid than acetic acid. Why it is? Then you have to understand what is this formic acid and acetic acid is. What is formic acid? SCOH. What is acetic acid? It's a CH3COH. But it says formic acid is stronger than acetic acid. Why? So because the CH3 group is an electron donating group. It decreases acidic nature. By what effect? It is having a plus effect, sir. Plus psi inductive effect we call it as. So what may be the option? Where is the plus side? So plus side. C is the option. C is the option. The reagent with which both acetaldehyde and acetone reacts. Acetaldehyde and acetone reacts. And we know that ketones will not react with the weak oxidizing agent. What is it? Acetone. So it's a ketone. And ketone will not react with no. With what? Tollens reagent and falling solution. So what will be the option then? Is it iodine and NaOH or carbonic acid? What is iodine and NaOH? It is nothing but iodoform test. Is nothing but iodoform test. Who else can give iodoform test? Only those with CH3CO group can give it. R. What is R? R may be carbon or hydrogen. What is acetaldehyde? So acetaldehyde is CH3CHO. They have the CH3CO group, sir. They have the CH3CO group. So it can give. What is acetone? Acetone is also CH3CO, CH3. So there also you are having CH3CO group. So it can give iodoform test. So what is the option, sir? It has to be B, sir. It has to be the B. Yes, sir. B is the answer. Which are the following gives in aldehyde and dry distillation? Again, 2011, I told you, what is the shortcut? If format is there, you end up getting aldehyde. If it is not there, in all these cases, calcium format is not there, so they give ketone. Who will give aldehyde? Only A will give aldehyde. Oil of wintergreen. I told you it's a methyl salicylate. What is a methyl salicylate? It's a derivative of salicylic acid. What is salicylic acid? OH and COOH. Where instead of H, you'll be having a CH3. So this is a ester, sir. It's a ester. Yeah, organic compound A burns with sooty flame. It is negative towards tolerance reagent test, positive for burst reagent. The compound A is. What may be the option? He only says negative means it's a ketone. So it has to be ketone. And there's only one ketone. Oh, one more is there. So it has either acetophenol or acetone. So benzaldehyde cannot be, salicylic acid cannot be. Why, sir? He says negative towards tolerance reagent. That means he is a ketone. And he says burns with sooty flame. Will burns with sooty flame, we have studied. Aromatic compound. Who is aromatic compound? Sir, acetone cannot be aromatic compound. So this is not the C. B, what is acetophenol? Is having benzene ring. So it gives us sooty flame. COCH3. So let us check it out. Yes, sir. B is the answer. A formaldehyde was treated with reagent X. A product formed upon hydrolysis in the presence of an acid gave alcohol. The reagent X is. What will be the reagent? Already I told you how to remember this one. We have discussed in preparation of alcohol. Look at it. We are studying about aldehydes. No. But we are studied in alcohol. What we have studied? Formaldehyde when reacts with RMGX and further hydrolysis. gives you what? Primary alcohol. Sir, any other aldehyde? Any other aldehyde gives you secondary alcohol. Sir, ketone gives you tertiary alcohol. That's it. So I need alcohol. You're getting alcohol. Which is this alcohol? So primary. Primary means you need what? RMGX. RMGX means CHMGI. So D is the option. The relative acidic strength of benzoic acid, orthotolic acid, paratolic acid is of the decreasing order. Decreasing means from highest to lowest. ಯಾವ್ದಾಗುತ್ತೆ? What will be the thing? First of all, what is a benzoic acid? Sir, COH. What is orthotolic acid? Means benzoic acid with CH3 group. It is called as orthoposition 2. Paratolic acid means where you are having CH3 at 4 position. This is para. In benzoic acid, there is something called as ortho effect. What is ortho effect, sir? Any group at ortho will increase acidic nature. So any group at ortho will increase acidic nature means this orthotolic acid is more stronger. So orthotolic acid, sir. Then comes benzoic acid, then comes paratolic acid. Why? The CH3 group is electron donating group and it decreases acidic nature. But here in ortho is a special case. That's called as ortho effect. So what should be the answer? So it should be orthotolic acid, then benzoic acid, paratolic acid. Should be D, sir, option. Let's check it out. Yes, sir. D is the answer. Next one. When formic acid is heated with concentrated sulfuric acid, the gas liberated is what? What is the gas liberated? What is formic acid? Sir, is COH. When you eat this one, what do you get? So one oxygen is taken by hydrogen to form H2O plus CO. That means only carbon monoxide you get, sir. Let's check it out. Yes, sir. B is the answer. The reagent used to distinguish between acetaldehyde and benzaldehyde is what may be the compound? So with 2,4-DNP, both aldehydes and ketones will react. Semicarbazide, both aldehydes and ketones will react. So they cannot be Telling solution. So this also to some extent, okay, aldehyde will give. And this is also given by aldehyde. So these two can be the option. Ketones will not give. So then which reagent we can use it to distinguish between acetaldehyde and benzaldehyde? So these both are aldehydes. Both are aldehydes. Then what we can use? Then you have to understand the composition. Ammoniacal silver nitrate. And this is, sir, copper sulfate and NaOH. What may be the option? So benzaldehyde will not react with NaOH because when they react with NaOH, they undergo Cannizzaro reaction. They undergo Cannizzaro. Say they do not react. Whereas with Tollens reagent, they both will react. So only one is left behind, sir. Option B may be the answer. Let's check it out. What is the answer? Yes, sir. B is the answer. Take a screenshot. Iodoform reaction is answered by all except we will not answer it. Immediately, what is iodoform reaction? Organic compound reacts with iodine plus NaOH to give you yellow precipitate. What is yellow precipitate? CHI3. So what kind of compound will give this one? Any compound having general formula RCOCH3, where R may be carbon or hydrogen. Or anyone having the general formula RCHOHCH3. They can give this. So let us check it out. Yes, sir. Here, next to CHOH, there is a CH3. So you will give it. So this is not the answer. Next, CH3CHO means there is a CO group. Yes, this is also not the answer. Then there is a CHOH next to CH3. Yes, this will also give not the answer. Here, sir, CHOH is there. Next to CH2. Yes, sir. Here, iodoform reaction will not take place. That is the answer. Next one. What may be the option? Sir, benzoic acid reacts with ammonia. Then it reacts with NaOBr. Then it reacts with sulfuric acid. What it gives? So when it reacts with ammonia, the OH gets replaced. So what you get, this P is nothing but C6H5CONH2. What is this? This is amide. And when this triad undergoes Hoffman-bromamide reaction, sir, Hoffman-bromamide reaction. This we have studied in amines. Gives you amine. What is amine? C6H5NH2. So we get aniline. Aniline undergoes sulfonation. What do you get? Sulfonic group is added, sir, to the aniline. What is aniline? Benzene with NH2, no? You are adding SO3H group here. That's it. What is this one? This is called as benzene sulfonic acid. This part is called as what? Benzene sulfonic acid. And here at 4, what you are having? Amino. So 4 amino. Benzene sulfonic acid. So 4 amino. Benzene sulfonic acid. 4 means para. Para amino. Benzene sulfonic acid. This is also called as commonly sulfonylic acid. Sulfonylic acid. What is sulfonylic acid? Option C. Take a screenshot. Let's check it. Yes, sir. Option C. Now let us answer few last year problems. So 2019. Which are the most suitable reagent for the following conversion? So what we have done, we have converted the CO group into what? Carboxylic group. What will be the best for it? So what is happening here? Here, you have removed this CH3 group. This group is removed. And who can remove it? Only iodoform reaction can remove it. Why, sir? That part will become CHI3, yellow precipitate. The remaining part becomes carboxylic acid. Carboxylic acid. So option B, sir. Then look at this reaction. What is happening here? If you observe very carefully, this CH2OH and CH2OH is remaining same. Only aldehyde is becoming alcohol. That means it's a reduction. Reduction. So what you have to use for these kind of things, we have to use sodium borohydride. Means at 2 places are there. So let's first one is NaBH4. Then we'll go to next one. Look at here. CH2OH is there. That has become aldehyde. Alcohol has become aldehyde. That means it's an oxidation. What we have to use? Oxidizing agent. Which one? PCC. So we have to use next PCC. Sodium borohydride and PCC means what? Option C, sir. Option C. What is the option? This one. It's not the B, it's the option C. So here, to make correction, it's not option B, it's the option C, and it's not KMNO4, it's a PCC. Propanoic acid undergoes a Switzer reaction to give chloropropanoic acid. And we know that when chlorine is there, it increases acidic nature, is a withdrawing group. So stronger acid than propanoic acid. Let us take a little bit about surface chemistry. In surface chemistry, first thing what we have to discuss is adsorption. What is adsorption? It's a surface phenomenon where the molecular species will accumulate on surface. It's a spontaneous, that means delta G is negative. Exothermic, delta H is also negative, leads to lowering of entropy. Delta S is also negative. And what is adsorbate? The sustained adsorb. Adsorbent, the solid. Desorption, reverse of adsorption. Occlusion, adsorption of gases and metals. What is the difference between physical and chemical adsorption, sir? Physical adsorption is not specific, whereas chemical is specific. Here, activation energy is not required. Here, EA is required. Here, it is a weak van der Waals force, but here it is a strong chemical bond. And so, enthalpy of adsorption is very low, 20 to 40, but here it's very high, 82 to 40. So, high temperature is required. Here, low temperature is required. And physical is reversible, and this is irreversible. And in physical, multilayer is formed, here monolayer is formed. Okay, so please remember this difference between physical and chemical adsorption. Then factors affecting adsorption. Surface area, more the surface area, more the adsorption. Nature of adsorbate. Okay, and sometimes only those adsorbent which can form a chemical bond can adsorb the species, otherwise it is not possible. It also depends on the temperature, remember this one, and nature of a adsorbate also. Friendly adsorption is a term. What is that? It is mainly explains physical adsorption. Okay. What is adsorption isotherm? When you plot X by M against pressure, you get a curve. We call it as a isotherms. Okay. And here, the chemical equation for this friendly adsorption isotherm is what? X by M is proportional to P. ಅದನ್ನೇನ್ ಮಾಡ್ತೀವಿ ನಾವು ಎಕ್ಸ್ ಬೈ ಎಂ ಇಸ್ ಇಕ್ವಲ್ ಟು ಆ ಪ್ರಪೋರ್ಷನ್ ತೆಗೆದು ಕೆ ಹಾಕ್ತೀವಿ ಪಿ ಟು ದಿ ಪವರ್ ಆಫ್ 1 by n ಅಂತ ಬರೀತೀವಿ ವೇರ್ ಎನ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ 1 to infinity 1 to infinity. ಸೊ ಈ ತರ ಮಾಡಿದಾಗ ನಮಗೆ ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಸಿಗಲ್ಲ, ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತೀವಿ ಲಾಗ್ ತಗೊಳ್ತೀವಿ. ಲಾಗ್ ಎಕ್ಸ್ ಬೈ ಎಂ ಇಸ್ ಇಕ್ವಲ್ ಟು ಲಾಗ್ ಪಿ ಮಾಡಿದಾಗ ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಬರುತ್ತೆ, ಸ್ಲೋಪ್ 1 by n ಆಗುತ್ತೆ, ಇಂಟರ್ಸೆಕ್ಷನ್ ಲಾಗ್ ಕೆ ಆಗುತ್ತೆ. So we can also classify this particular adana colloids. What is a colloid? Colloid is a heterogeneous system. You know that one, where particles is 1 to 1000 nanometers. There are two pairs. One is dispersive phase, another is dispersion. Okay, example is star solution, protein solution, all these are colloids. If it is less than 1 nanometer, we call it as a true solution. Or they also called as crystalloids. So more than 1000 nanometer, we call it as suspension. Remember this one. These colloids, based on physical state of dispersive phase and dispersion medium. What is dispersive phase? The suspended particle. And dispersion medium, the medium in which particle is suspended. Based on that, we can classify it as solid, sol. There is a solid in solid, solid in a liquid, aerosol, solid in a gas, gel, liquid in solid. Liquid in liquid means emulsion. Liquid in gas means aerosol. Gas in solid means solid, sol. Gas in liquid means foam. So this is a classification based on physical state of a dispersive phase and dispersion. Based on the type of particle. This is a classification based on type of particle in dispersive phase. In dispersive phase. We can classify it as multimolecular. Large number of small molecule aggregate to form a colloidal particles. For example, gold salt. Macromolecular. Each molecule is so big that they themselves can form a colloid, like starch solution, protein solution, polyethylene solution. Associated colloids. When many molecules associate, like soap ions, they associate to form a big particle of colloidal size. This is called as associated colloids. Best example is micelles. They form these micelles at a critical micelle concentration at as craft temperature, above which the formation of micelles take place. This is classification based on types of particles. So this is the classification based on affinity between, affinity between dispersive phase and dispersion medium. Lyophilic and lyophilic. Lyophilic, it loves water. Is highly hydrated. They have a greater affinity. Lyophilic, they have a lesser affinity. These are less stable, lyophilic is more stable. These are reversible, these are irreversible. They can be coagulated since they're less stable, but they cannot be coagulated easily. More hydration here, but here less hydration. So this is the difference between lyophilic and lyophobic. Next we'll go for different ways of preparing colloids. We can prepare it by mechanical method. Either we can prepare it by dispersion method or by condensation method or by peptization. We convert the precipitate into colloids by using electrolyte. We can purify the colloids where we use dialysis to remove the true solution, where we remove the true solution particle or crystalloids. When you apply electric current, we call it as electrodialysis. When we use ultrafilter paper, we call it as ultrafiltration. The zigzag movement, we call it as a Brownian movement. The scattering of light by colloidal particles, we call it as a Tyndall effect. Only those colloids where the diameter of the dispersive particle is more than the wavelength, they can scatter. Refractive index of dispersive phase and dispersion medium should be high. Only they can give Tyndall effect. What is coagulation of colloids? We can convert colloids into precipitate. We can convert colloid into precipitate by adding electrolyte. That process we call as coagulation. If colloid is having positive charge, we use a negative ion. If the colloids are having negative charge, we use positive ion. Positive ion to precipitate. We call it as coagulation. It follows Ardisco's rule. What it says, more the valency, more the coagulation. So more the valency, more the coagulation. We can also call it as flocculation value. What is flocculation value? It is the minimum concentration of electrolyte required in millimoles to cause precipitation of 1 liter solid in 2 hours. We call it as a flocculation value. Sometimes we use also, and this also you should remember, electrokinetic potential. What is that? Each colloid is having a charge. Some charge it will be there based on its absorption of ions. And this layer absorbs another layer of charge, minus and it attracts. And this double layer, this electrical double layer, there develops a potential called as electrokinetic potential or zeta potential. Then gold number. What is a gold number, sir? This is to prevent the coagulation of a colloid, we add lyophilic colloid. So lyophobic, we know that it is very highly unstable. So when you add electrolyte, it coagulates, it precipitates. And you can prevent it by adding lyophilic colloid. That is called as gold number. We can measure it in terms of milligrams. Milligrams of lyophilic colloid required to prevent the precipitation of 10 ml of cold salt, an addition of 1 ml of 10% NaCl solution. Lesser the gold number, more is the production capacity. So catalyst. What is a catalyst? Any substance which increases or decreases the rate of a reaction. What is a promoter? Which increases the efficiency of a catalyst. Poison decreases the efficiency of a catalyst. For example, in our process, iron is the catalyst, and their CO or H2S act as a poison. Homogeneous, where all the things are in the same phase. Heterogeneous, some of them are in a different phase. Shape selective catalysis. What is that, sir? Where some catalysts act based on the pore structure of catalyst and the size of the reactant and product. Example, zeolite, sir. What is biocatalyst? Enzymes, we call it as a biocatalyst. Let's take a few examples. An example of an autocatalysis is, which we can take it as an example for autocatalysis, sir. What is autocatalysis? Where one of the product itself acts as a catalyst. In a reactant gives to product. Say if you get multiple product, one of the product itself acts as a catalyst, that we call it as an autocatalysis. You have done the titration of oxalic acid and KMnO4. When KMnO4 oxidizes oxalic acid, what is oxalic acid? COH. And facilitated reaction will add some bit of sulfuric acid. The oxalic acid gets converted into CO2 and H2O. And your KMnO4 gets reduced to what? K2SO4 and MnSO4. And here, MnSO4 itself acts as a catalyst. That is called as autocatalysis. Which of the following electrolyte will have a maximum flocculation value for iron hydroxide salt? So he has given a FeOH thrice. So what is a FeOH thrice? Is a ferric hydroxide. The ferric hydroxide. And we know that flocculation value is inversely proportional to coagulation. Lesser the flocculation value, more the coagulation. He's asking who is having maximum flocculation value. That means lesser coagulation. Lesser coagulation. What may be the answer? Sir, A is the answer, which is having a lesser coagulation. When sulfur salt is evaporated, sulfur is obtained. On mixing with water, sulfur salt is not formed. The sulfur salt is. What will be the option? When it does not like water, we call it as hydrophobic. Sir, option C. C is the answer. It has no affinity for the water molecule. Then they're called as what? Lyophobic colloid. Or also hydrophobic colloid. Dalda is prepared from oils by what? What is dalda? It's nothing but a fat. So you're converting oil into fat. Oils will have a double bond. Fats will have a single bond. That means you're doing reduction. Adding hydrogen. Adding hydrogen. So what may be the option? So D is the answer. The color of the sky is due to. Why? There we say it appears blue. That's because of scattering of that particular light. We call it as, what is the option? Sir Caesar. The basic principles of quarter precipitator is what? What is quarter precipitator? Say, you are having a factory and you are producing a lot of toxic gas. Lot of toxic gas. So what will happen? The government will object to it. So what you have to do? You put a one electrodes here, one positive electrode, one negative electrode. The smoke which is coming out, if it is having any toxic particle, they get attracted to this positive electrode or negative electrode. So the smoke which is coming out will not have a toxic components. That is what quarter precipitator is. It neutralizes the charge and color particle and attracts it. What should be the option? So it should be option A. Rate of physical adsorption increases with what? Here, enthalpy of adsorption, we say, is only 20 to 40 kilojoules. So low temperature is required, that is decreasing temperature. Sir, option A. Let us check it out. Option A, sir. Low temperature will favor it. During adsorption of krypton on activated charcoal at low temperature, what should be the condition? What should be the condition? We know that during adsorption, delta G should be negative and delta H should be negative. That means less than 0. Delta S, entropy should also be negative. Less than 0 means, sir, option B. Which one of the following does not involve coagulation? Does not involve coagulation. Yadagutte. Does not involve coagulation. Formation of delta in backwaters is due to coagulation. Drinking water by potash alum is coagulation. Clotting of blood is a coagulation. Then what is remaining? Sir, peptidization. What is peptidization? Converting a precipitate into colloid is a peptidization. So this is not a precipitation. So there is not a coagulation. Option B, sir. B is the answer. Which one of the following statement is true? ಯಾವ್ದು ಸರಿ ಹೋಗುತ್ತೆ? What may be the option? So saponification of oil yields what? Soaps. So ತಪ್ಪಾಯ್ತು sir. Drying of oil involves oxidation, polymerization, not hydrolysis. So all these are wrong. Addition of antioxidant to oil minimize rancidity. So rancidity is due to what? Oxidation. And antioxidants prevent it. Yes, sir, this is right. Option C is the answer. Which one of the following is an example for homogeneous catalysis? Homogeneous means what? All should be in the same pace. What may be the option? Sir, if you look at the hydrolysis of sucrose, everything is in a same pace, sir. Then option should be option C, sir. Hydrogenation of oil? No, sir. Here, catalyst, what you use is a solid. This cannot be. In manufacture of ammonia, iron is a solid, cannot be. So option is C, sir. C is the answer. Well, everything is in a liquid phase. During absorption of gas on the surface of a solid, which of the following is true? Already I told you, during absorption, everything should be negative. All should be negative, means it should be less than 0. Everything should be less than 0. What is the option? Sir, only one. Option C is there. That has to be the answer, sir. All colloidal dispersions have. What they have? They have a very low osmotic pressure. Next one. The stability of a lyophobic colloid is due to what? What may be the option? The stability of a lyophobic colloid is due to it is mainly due to what? Charge on the particle. That is option C, sir. Which of the following cations will have a minimum flocculation value for arsenic sulfide salt? Minimum flocculation value for arsenic sulfide salt. Depends on Ardiscu's rule. So depend on Ardiscu's rule. What it says, more the valency. Sir, more the coagulation, more coagulation. Who is having more valency? Here, aluminum is having more valency. So this is cause more coagulation. Cause more coagulation. That means it will be less value. It will be having less flocculation value. Yeah, so D is the answer. Let's check it. D is the answer, sir. Adsorption theory is applicable to what? So applicable to heterogeneous catalysis. For friendly consumption isotherm, graph of log X by M is plotted against log P. ಹಾಗಾದ್ರೆ ವ್ಯಾಲ್ಯೂ ಏನೇನು ಬರುತ್ತೆ? So what may be the value? You will plot X by M against log P. Iವಾಗ we get straight line. The slope will be 1 by n, sir, and intersections will be log K. So 1 by n log K, it should be the option C, sir. Option C is the answer. Make a small calculation. What is the energy of activation? What is slope? He says A by R. So the slope is equal to A by R. What is slope? Yes, given already. -1 into 10 to the power of 4 is equal to A. R is constant, we know, 8.314. 8.3. Just cross multiply, just over. What is the answer? It is around 83.14 it will come. What is the options? The last options are D. 83.14 kilojoule per mole. Gold sol is not what it is not. Gold sol, we make it by Brady's electric arc method. It is formed by association, so multimolecular. It is a lyophilic causer. It is negatively charged. But what is not? It is not a macromolecular. Then option is that one. That is the option. So it is not a macromolecular. It is a multimolecular. What is macromolecular? Starch is macromolecular. Proteins are macromolecular. Enzymes are macromolecular. Which of the following colloid cannot be easily coagulated? Easily coagulated. And we know that lyophilic are unstable. So they're unstable. They can be easily coagulated. And irreversible also same thing. And most of these lyophilic are multimolecular. So answer should be macromolecular, sir. They're a bit difficult to coagulate. D is the answer. Yes. The electrolyte having maximum flocculation for AgI, Ag plus is. So he only says you're having what charge? This colloid is having positive charge. That means you have to precipitate it by adding electrolyte. And then which ion is important now? For positive colloid, negative ion is important. Which is the negative ion? Let us take. Yeah, Cl minus S2 minus, PO4 3 minus, sulfate minus. So who is having more valency? This fellow is having more valency. So you'll be having more potential to coagulate. Here, more coagulation take place. More coagulation means lesser flocculation value. But question is not lesser, he's asking maximum. Then who is less coagulation? This fellow. He will cause less coagulation. That means you get more flocculation value. Next one. Which of the following curve is in accordance with Frendick adsorption isotherm? I told you log x by m is plotted against log p. You get slope of 1 by n. What is the option? Sir, option D, sir. Option D. Which of the following statement is incorrect with respect to physical adsorption? What may be the incorrect statement? Sir, van der Waals force? Yes, van der Waals force is involved. Easily adsorbed? Yes, sir. They form multi-molecular layer? Yes. They're low and they're not positive, they are negative. So D is the option, sir. Reaction in zeolite catalyst depends on. It depends on all the things. It depends on pore size, apertures, everything. Answer is sir D. All of these. Let me see whether it is right or wrong. Yes, sir, D. Which of the following is not a favorite condition for physical adsorption? Physical adsorption, I told you, enthalpy of adsorption is only 20 to 40. That means high temperature we should not use. It has to be option C. Let us see whether it is the option C. Yes, sir, C is the answer. The process which is responsible for formation of delta at a place where river meets the sea, I told you, is nothing but a coagulation. All sand particle, they get coagulated by salt in sea. Salt in sea. Hydrogenation of vegetable oil in presence of finely divided nickel catalyst. The reaction is known as what? Here, oil is also liquid, but nickel is a solid. So it has to be heterogeneous catalysis. Let me see. Is it right? Yes, sir, it is a heterogeneous catalysis. Which of the following is a homogeneous catalysis? Homogeneous means what? It should be same pace. Sir, here we use SO2, no? We use oxygen, gas, to form SO3, gas. And also we use nitric oxide, that is also gas. So what should be the option? Sir, C, sir. C is homogeneous. Then critical micelle concentration for a soap is 1.5 into 10 to the power of -4 mole per liter. Micelle formation is possible only when the concentration of soap solution in mole per liter is What is CMC? I told you. Above which it forms a meson. Above which it forms meson. Means the value should be more than this one. Value should be more than this one. He has given a negative. That means you should go towards 0. Means 0 means you should go like 10 to the power of minus 3, 10 to the power of minus 2, like that you have to go. Towards 0 you have to go. What is the option? Sir, option A. A solid of AgI is prepared by mixing equal volume of 0.1 molar AgNO3 and 0.2 molar K. Which of the following statement is correct? So it depends on the adsorption. Depends on the adsorption. If AgI adsorbs Ag plus, it gets a positive charge. If it absorbs I minus, it gets a negative charge. This depends if you take Ki in excess. Ki in excess. Where it is happening in option C. So there you get a negative solve. Negative solve means colored with a negative charge. You can check. Yes, sir. Option C is the answer. Okay, dear students. Today we have completed all the 3 chapters what we have taken. Please complete practice also. I have taken most of the questions from previous year. Okay. This chapter, organic compound containing oxygen, is a very important chapter for our CET. Remember this one. Where I have covered both 1 and 2, and also another important chapter, surface chemistry also. Thank you. Thank you all. Verma sir, are you there?
Thank you, sir. Thank you very much for the very interactive session. I hope student will get the good input from this session. And tomorrow, as usual, 4 o'clock, the class is there. So
Okay.
tomorrow session is mathematics. It will be taken by the Mallikarjun Rao sir. So dear student, you be in time, join 10 minutes before, so that you will not miss anything. And you can interact as usual. Who are the present here, they are interacting very well. If you will interact, you will come to know, your doubt can be clear, and you can do well in the main exam. Thank you, sir. Thank you very much.
Yeah, thanks.
Students who are planning for the BSAT exam, the 29th, 30th April online home-based test is there for those are planning to write the BSAT exam for Dayanand Sagar University admission. The online applications are open, and student can fill the application form, and sitting at any part of India, they can sit at home and they can write this exam. This is online home-based proctor test. So this result will be out within 2 days. The result will be out, and based on that you can proceed for the admission. Thank you very much. Have a nice day. Good night. Ravi, thank you. Closing. Students can get the recordings also. Recordings link also we have shared. Please note down that. Thank you.